Dr. Charlie Bamforth joins me this week to discuss quality in beer. This is BeerSmith Podcast number 184. This is BeerSmith Podcast number 184, and it's late December 2018. This week, Charlie Bamforth joins me to discuss quality in beer. Thank you to this week's sponsors, Craft Beer and Brewing Magazine. They have a new Craft Beer and Brewing Magazine podcast, which I encourage you to check out. It features some of the top craft brewery owners and brewmasters discussing brewing techniques and flavors in beer. It's the podcast for those who make and drink great beer. You can find it on iTunes or at beerandbrewing.com/podcasts. And also the Riptide Pump from Blickman Engineering. Designed for homebrewers, this pump features a whisper quiet sealed housing, a removable tri-clamp stainless steel head that's easy to clean, and a built-in relief valve for easy priming. It also has the integral Blickman linear valve for precise flow control. Get the Riptide Pump together today, another great innovation from BlickmanEngineering.com. Again, that's BlickmanEngineering.com. And finally, BeerSmith 3 is now available for download, and also the mobile version is out. BeerSmith 3 adds mead, wine, and cider recipe support to the BeerSmith platform, along with new integrated water profile and mash pH tools for beer brewers. Dozens of new features, including cloud folders, updated databases, support for fruit, juice, and honey, as well as new Whirlpool's hop options. Download your free 21-day trial today from BeerSmith.com. And now let's jump into this week's episode. Today on the show, my guest is Charlie Bamforth. He's professor of malting and brewing science at the University of California, Davis. Dr. Bamforth specializes in the study of wholesomeness and beer, including beer perception, polyphenols, foam stability, oxidation, and flavor stability. Charlie, it is always a pleasure to have you on the show.
Thank you. I've always enjoyed being on the show, so thanks for inviting me again.
I think this, I can't remember, 7th or 8th time, something ridiculous like that.
I don't know. I've lost count. Can't you find anybody else?
No, I have trouble. Well, I had you on about once a year, so it's not that bad, I guess. I've been doing this for 7 years now.
Right. Oh, there you go.
So I understand you're getting ready to retire. Can you tell us a little bit about that, your plans of retirement?
Yeah, I retire at the end of December, so quite excited. 41 years in the brewing industry. Doesn't mean that I'm going to disappear. I'll still do things, but I'll learn to say no a bit more often, and I'll be avoiding committees and things like that.
But you'll still do the podcast, right?
Oh yeah, if invited.
Okay.
Yeah, if we've got anything left to talk about. Yeah, I'll still do some of the teaching on what we now call continuing and professional education. We used to call it extension, and one or two other irons in the fire. I'm also going to do more of my soccer writing as well. I'm already lined up to work with a famous former player to do his autobiography. And
are you really? Because I remember you did the book on, of course, the very famous book on soccer goalkeepers, right?
Oh, yeah, absolutely legendary book on the goalkeepers of Wolverhampton Wanderers Football Club. But no, actually, it's a guy who used to play for the Wolves and for England, and for the longest time has been over in the States. So I'm working with him, and I'm excited about that. But yeah, I'll do bits and pieces. I went around the world with my wife recently. After about 4 or 5 weeks, she said, "You know, retirement, you are going to do something, aren't you? Stay at it."
Yeah.
Stay out of my hair. I said, "Yeah, I'll stay out of your hair." So,
yeah, when I started working from home, my wife said I needed to get out of the house more. So,
yeah.
You know how that is.
I know exactly how it is. Yeah.
Well, we're looking forward to seeing you again, though, I hope, and very excited about your book on soccer, of course. How many books have you written now? I'm trying to remember now.
It's over 20. The very first one was all about something called Methylotrophy. That's a long time ago. But yeah, about 20 on beer and then food and fermentation. And this will be my second soccer book. But I've written over 1,000 articles on soccer, which is actually more than I've written on beer. But
that's pretty astounding.
Yeah. So I enjoy it, both. I'll never forget. I was at a former players' dinner at the club, Wolverhampton Wanderers, a year or two ago, and somebody introduced me to his wife, and he said, "This is Charlie Bamforth. He writes about beer and football, and he does one of them very well." And I said, "What the hell does that mean?" But take your choice.
Nice. Well, today, getting back to beer, we were going to discuss beer quality. And I know you've done some writing on that subject as well. But to start with, let's talk about how you define quality in beer.
Yeah, it's like everything else. Quality is a tough thing to define because what one person judges as good quality, somebody else hates. So you might judge a certain style of beer as being a great quality, and you might say another style of beer is rubbish, but somebody else might like that other style of beer and think what you like is rubbish. So it's really what you define it as in terms of what appeals to you. My favorite definition is there's several. One is a product that does not come back, sold to a customer who does come back. Another one is the correspondence between expectation and realization. And I think that encapsulates it. So quality to me is the product that you expect, that you enjoy, that you want every time. So consistency, consistent delivery of what you have defined to be your definition of a quality beer in this instance. Yeah. So it really is consistency. Somebody emailed me a while ago, quite a long while ago, and they said, you keep talking about consistency, and I like surprises. And I said, if you fill your car up with gas and it can't leave the garage, the filling station, because the car doesn't work, are you happy? Is that a surprise that satisfies you? Or, if you're having an operation and the anesthesia doesn't work, are you happy? It's beer is like anything else, in my opinion. It should meet your expectation, and that's the definition of quality.
And it's, I assume it's from the perspective of the end user too, right? Not because a lot of
Precisely.
times what the end user has is different than what leaves the brewery.
Well, and that is part of the problem, and that is a large part of the problem, that by the time the beer gets to the consumer, it may have traveled a very long way through who knows what conditions. I think we've talked about flavor stability before. And so, if there's a beer that's brewed in, let's say, England, for the sake of argument, by the time it gets to California, it really doesn't taste like it is expected to taste in England. Now, that might be what somebody's used to over here, and therefore they've established that is the quality they're expecting. And it's rather different to the original beer as it was brewed. I might have used this story before on this podcast, but not this particular one. But I was the QA manager of one of the Bass breweries in the northwest of England, and we made Carling Black Label and brewed Carling Black Label like several other breweries in the group. And we used to get criticized because our Carling had a grainy flavor, and they, in no uncertain terms, told us we had to get rid of it. So we did get rid of it, and Bass were happy, but the customers weren't happy anymore. They started sending the beer back saying, "What the hell have you done to the beer?" Because we'd changed it. So really it's whatever the customer expects. So if your customer's a long way away, it doubles the challenge, or multiplies the challenge, because your beer is going to age. Now, if you're brewing in a bucket at home and drinking it comparatively quickly, then of course some of those problems don't apply. But I still think, even if you're brewing only for your own satisfaction, I still think that if there's a certain beer you want, I think you want it to be the same every time. If I do some cooking, which my wife doesn't allow me to do very often, but when I do, and I know what I'm good at making, that's what I want to make every time. And I want it to taste the same every time. I don't want it to taste totally different. And I think it's the same for beer.
Well, moving down the list here, what's the difference between quality assurance and quality control? Because they're not really the same thing.
No, they're not. Quality control is basically a reactive thing. So you make a measurement just to check everything's okay. and it's within specification, and if that beer is going to be sold, that everything's as it should be, and it can leave the brewery. Quality assurance encompasses quality control, but really it's the overall quality ethos. So quality assurance is setting everything up such that things are going to go well, and you've got a process, you've got raw materials, you've got everything in place to make sure that at the end of the day everything is geared towards assuring the quality. Now, you will make measurements at various places. You might measure some of the elements of the raw materials and certainly the process and the product, just to make sure that everything is on target. And so that's the quality control. But the quality assurance is the state of mind. It's the putting in place everything you need, whether it's equipment, whether it's training, whether it's quality systems and processes and control documentation and all that good stuff that is going to ensure that things will go according to plan. Including, just if you take the kitchen analogy, including following a recipe and making sure that you do it consistently and do it well. And at the end of the day, things will be hopefully within specification. And then you can check those with a QC check. If I give you a specific example, it's ironic actually. I gave my last ever class on campus last week, and a grateful student gave me a bottle of beer and said, "I'd like you to have one of my beers." So I put it in the refrigerator, and I got around to opening it yesterday, and it gushed. I've never seen gushing like it in 41 years. I mean,
I've had that happen myself.
It was spectacular. What a mess. And I'm thinking, my God, if this is what I teach the students, and But I'm not quite sure exactly. I think I know why it was gushing. There's some pretty strange particles in there. But the classic example of causing gushing on the planet is contaminated barley. Now, I don't think that was the reason in this case, but if barley is contaminated with fusarium, which it will be in a fairly cold, wet, and dank northern European country, then that fusarium will produce a gushing factor. And therefore, you would be best advised not to use that barley. So the quality assurance would be, just taking a look at the barley to make sure it's not contaminated. Quality control would be testing the finished beer to make sure it's not gushing. And if it is gushing, well, how stupid. You've gone through all that raw material and all that process to end up with a product that is not acceptable. So the Q say, okay, you're not putting a gushing beer out into the marketplace, but the QA is, throughout the process, including at the very start, making sure that things are set up to make sure that at the end of the day, your product is not going to be a failure.
Well, most large commercial breweries have a pretty extensive quality program in place. What are some of the common elements when we look at a program like that?
Well, the first thing you've got to have is commitment from the very top. You've got to have somebody at the helm who is committed to doing things right. And there are several notable examples that I could think of. I mean, the one that readily springs to mind is somebody like Ken Grossman at Sierra Nevada, who believes in absolutely and utterly that everything should be of a quality nature, whether it's the architecture right the way through the process to the finished product and the people. So you've got to have the commitment and the drive from the top. And another old boss of mine at Bass Brewers used to say there are two things that matter. One is the people, and the other is the quality. And if you look after the people, they will deliver the quality. And so another thing you've got to have a quality operation is the proper people in place. Now, I realize most of the people listening to this are homebrewers, and the people are basically one. But on a commercial scale, if you look after the people and make sure that they have all the tools at their disposal and the training, then you have a chance of achieving a quality product. So you've got to have specifications in place. So your raw materials need to be specified. You need to know what you're handling so you can deal with it properly. and you've got to have the proper processes in place. And so it's critical to have the standard operating procedures, the analogous to that recipe in the kitchen. I often tell the story that I came to California in 1999, and I was asked if I audited breweries, and I said, yes, I do. And they said, well, how much do you charge? So I gave them a high cost and a low cost. They said they will go for the low cost. And they said, what do we get for that? I said, well, I'll come down the first day and I'll look at your standard operating procedures and also your records, your data. The second half day, I'll look around the brewery, and the third half day, I will report back. And the first day I arrived, and there were a couple of boxes. There was a fairly large box with assorted numbers in it that really were random. And the second box had one piece of paper in it, and this was the standard operating procedure. And it said, to tighten the mill, turn the knob towards Golden Gate Bridge. And that was it. And that was it. And I know they'd been through 3 brewers already that year, and the only standard operating procedure was the restroom is over there. And if you don't have this standard way of doing things, and you know exactly what you're doing, then you can't hope to have a consistent process and a consistent product. So documentation, that's a key element of things. And sure, you've got to have everything in place. So you might, depending on the size of the brewery, you've got different extents of instrumentation, and right the way through on the smallest possible scale, your instruments are dangling around your head. There's one at the front with 2 nostrils on it. There's a mouth below it, and your eyes, and what you can hear, and you could achieve a great deal of quality consistency using those very sensitive tools. But on a somewhat larger scale, you're going to have a greater battery of instrumentation that's going to allow you to do some fairly fundamental measurements. They don't have to be too extensive, and so much is achieved by designing things properly, by making sure that you have got the right equipment and you operate it consistently on any scale. Now, some brewers on the larger scale will document all this in sort of things like the ISO system, the 9000 series, and all this documentation of how they do things consistently. But even then, you can document that you'll do things consistently, but you may not have the best targets. Let me give you an example. Say you want to achieve a certain oxygen level in the finished beer. And as I think we've talked about before, the lower the oxygen, the better from a point of view of flavor stability. Well, you can set that oxygen level really quite high. And as long as you achieve it consistently, you can get something like ISO 9000, but it might not be the ideal oxygen level. You're just saying you can consistently achieve that particular value. So it doesn't necessarily guarantee you're going to have the best beer. It just guarantees that you're going to produce that beer consistently. And ideally, it's a combination of knowing what the specification should be, but also having the systems and the techniques at your disposal to make sure that you are producing that same product every time.
Well, what are some of the things that we measure when we look at quality control? What are some of the elements that we might actually put a measurement to?
Well, there are so many, and some you will routinely need to check, and some less so. And of course, we're talking about measurements all the way through. So I think, starting with the beginning, you need to have some way of evaluating your raw materials. Now, let's say you're bringing in malt. Then few brewers these days will be really applying a huge number of tests. They will be putting the onus on the maltster to do that analytical methodology, and the maltster will be selling this malt and delivering the malt with a check sheet. So there'll be the range of key values, extract, protein content, moisture content, and so on, that you can actually check off to make sure that that particular batch has got the analysis and the values are within the specification range that has been agreed for that particular batch. Now, on a larger scale, brewers will audit the supplier. I realize that not every home brewer can go to a malting company and say, I've come to audit the plant, but on a significant scale, that's the way it's done. You enter into a relationship with the supplier, one based on trust and longevity, and we put the onus on the supplier to make sure that the malt is of consistent quality. And the same thing applies for the other key raw materials, notably the hops, for example. So there's the range of raw material specifications, but the very basic of that, for anybody, it should be a visual and a sensory evaluation of that raw material. So, for example, malt, then, it should be looked at. Is there any indication that some sort of spoilage has taken place, or there's contamination in there? Does it smell good? Does it taste good? Again, it right the way through, there should be this smelling and tasting. Take the number one raw material, water. In terms of quantitative contribution to beer, the majority of beer is at least 90% water. So if you don't make sure the water's of good quality, then you really are taking a terrible risk. And how do you do that? Well, you taste it and you smell it and you look at it. And what I recommend for anybody really is to carbon treat that water, to charcoal filter it or something, to take away any taints, as a quality assurance approach to making sure the water has got the right composition. And yeah, you can ask, you get your water supplier, you can look at the analyses. The only thing that they have to do is to make sure it meets the primary drinking water regulations and is not full of bugs and undesirable chemicals. And of course, we all know that the ionic composition of the water is going to be very significant for brewing. But again, you should know your supplier and what the supply is, and fundamentally make sure that it's not got taints in it. So depending on the brewery, there are all sorts of different analyses that will be applied right the way through the process. If you're on a large scale, we're going down now to, say, fermentation, you're going to be monitoring things and maybe monitoring them online. You're going to be monitoring specific gravity and pH drop and so on and so forth. Any brewer on any scale can measure specific gravity, so they need to be able to know how to do that so they can control strengths and so on. On a larger scale, you're going to be precisely controlling yeast pitching rates. On a small scale, it may be so many packets of yeast or what have you. So it differs on a different scale, but even on the larger scale, if you've got things configured correctly and you've got a standard protocols, as long as you are specifying and controlling your raw material supply and that process, at the end of the day, you should be in pretty good shape when it comes to the beer at the end of the process.
Yeah, Charlie, I've noticed every time I sit down with a bunch of professional brewers, they all are very religious about sampling the hops before they brew, whereas a lot of homebrewers just open a package and drop it right in without even smelling it.
Yeah, and that applies for all the raw materials, And I always jokingly say that the way you can tell a brewer as they're rubbing hops between their hands and smelling, the ironic thing is most of them are using pellets anyway and not using whole corn hops. But the point is that, every responsible brewer should be checking all of their raw materials. If I can mention the old Anheuser-Busch company, I mean, they were obsessed with tasting and smelling absolutely everything. So they would do the hop teas, they would do malt teas, the beechwood chips. Once they'd wash them and rinse them, they would taste the final rinse water. They would taste the rinse water at the end of a cleaning cycle to make sure that it was clean. Everything. The famous story is that the people going auditing the malt house would take with them a loaf of bread, and they'd take out a slice of bread and give it to the maltster and say, could you wipe that over the inside of the steep tank, please, and then eat it. and that was the encouragement to make sure that everything was clean, and all the way through, sort of sampling the raw materials, tasting them, and also looking at the process, and making sure the tanks were being cleaned properly. And so it's this touchy-feely, hands-on approach. And it's if anything, it's more straightforward for a home brewer than it is for somebody on that mega million barrel scale, because everybody can just taste that water before they use it and sample the malts and so on. It's very important.
Well, managing quality obviously comes at a cost. How do you balance and consider all the cost versus the time it takes versus the quality you're trying to drive into the beer?
Well, I often say that to people, those people who are owned by bean counters, and you give them an analytical measurement, say it's oxygen level, doesn't impress them. But if you tell them the cost of things, then it's going to impress them a lot more. Let me give you an example I often use. At the brewery I was the QA manager of, it was very badly designed. It was designed by engineers and not with consultation with brewers. And there were long pipelines with lots of pumps and so on. And it used to pick up oxygen, a lot of oxygen, and lose carbon dioxide. And so, you analyzed the finished beer just before packaging and found it, they still lost some CO2 and it picked up oxygen. So, you had to correct that. And the way you did it was to inject some CO2 and purge off the oxygen, and then you'd have to remeasure it. And if you just do that, and the bean counters don't understand, but if you say, it costs us this amount of money to actually make an analysis, then it costs us this amount of money to employ somebody to correct the CO2 content and the oxygen, and then we have to do the analysis a second time just to make sure it's okay, and then possibly a third time, and all that costs money. So the bottom line is what we used to call in BAS right the first time, which was if you get things right first time, you don't have to correct them, and that's the ultimate illustration, if you like, of quality assurance. Quality assurance is assuring it's going to happen the right time. The QC is, in that particular example, checking the gases, but the QA is basically redesigning that brewery to actually make sure it's going to be right first time. Now, it costs a lot of money to apply quality assurance and to put in place systems that are actually going to guarantee quality, but you will save in terms of rework, and you'll save in terms of the frequency with which analyses have to be done and so on. So you can actually divide the cost of quality into four categories. You can divide it into prevention costs, which is the cost of quality assurance, analytical or measurement costs, that's the cost of QC and making those measurements, and then the failure costs, both internal failure and, if you're commercial, external failure. So internal failure, I've just given you a classic example, the failure of getting the key gases in specification first time, and the cost of correcting that. There'll be lots of other examples. Let's say you had a stock fermentation, or let's say you ended up with a beer that was gushing, or anything that goes wrong actually within the brewery, no matter how small that brewery is. That's the internal cost of failure. But then external failure costs are, for if you're commercial brewing, the cost of it going wrong out in the trade. And I'll give you an example, and I will stress that this happened to BAS after I'd left. Just you need to be aware of that. But the biggest selling brand of beer in the United Kingdom is Carling Black Label, and that was the BAS brand. And they contrived to get glycol cooling liquid into the Carling Black Label. There was a leak on a heat exchanger, and glycol had got into the beer. And BAS, doing the honourable thing, announced that they'd got a problem, and they recalled the Carling Black Label from trade. Now, there's the cost of that, doing all the recall. There's the cost of replacement. There's all the emotional costs in terms of meetings and potential liability costs and so on and so forth. But the biggest cost issue was the stock price, which plummeted overnight because of a lack of trust, if you like, in that product. And of course, this happens all the time in various walks of life. You think of the automobile industry and the disasters there. In terms of things going wrong and recalls of vehicles and so on for all manner of reasons. And that really gives people a lack of faith in that particular product. And that's the cost of external failure. So it's very difficult to put a precise price on it, but quality at the end of the day is make or break. And if you present a bad product to people, they might give you a second chance. They might say, well, it can't possibly be as bad again. But, they won't give you a third chance. And that's why consistent, excellent quality is so important, and why it's worth putting investment into making sure it's done right. And in response to that, you will reap the financial benefit, both in terms of minimum failure costs, but also better sales. It's a no-brainer. You really can't avoid putting a lot of effort and investment in quality.
Well, what are some of the simple measurements, bringing this down to the homebrew level now? What are some of the things that you might be able to measure at home pretty easily? And also, what are some of the things you can do to sort of control your process? You mentioned, we already talked quite a bit about ingredients. But to make better beer at home.
Well, it's applying using the fewest possible measures, because most home brewers don't have a laboratory. It's using an interpretation of the data you've got, first of all, to make sure that you are able to operate your process consistently. So there's no reason, there's absolutely no justification for doing things differently every time. So the golden rule for achieving consistency is, as long as the raw materials are within specification, then handle them consistently every time. Now, it may be, there might be a different season's malt that is a little bit different, and you might have to just tweak the process, but tweak it in response to that. So if you know what your raw materials are and you've got a spec sheet, then you should be able to select, control quantities, solid liquid ratios and so on, to achieve a consistent mashing operation, for example. Everybody, I hope, has got thermometers and so on, so they can control temperature. And so controlling solid and liquid quantities and temperatures should be fairly straightforward. But again, it's consistency every time. And not forgetting those tools of taste and smell. And the similar sort of thing applying to the hops, in terms of, well, what is the alpha acid on this hop? And if I know how efficiently I can utilize that material and what my bitterness recovery is, then precisely how much am I going to add? When do I add it? How much do I add? What variety am I using, and so on? So, putting your faith in those raw materials, but applying them intellectually and using your knowledge to actually achieve that application consistently. Key, Brad, is to quality is a consistent fermentation. So again, it comes down to controlling the starting specific gravity, and everybody should be able to measure specific gravity. Providing the correct yeast in the correct quantity. So whatever tool you can apply to achieving a consistent pitching. Aeration and oxygenation, again, a consistent approach, making sure as much as possible, whatever way in which you're introducing oxygen or air, you're doing it consistently. The clarity of the wort, a lot of people ignore that. If the wort is bright, going into fermentation, or if it's cloudy and full of particles going into fermentation, you're going to have inconsistency. The more turbid the wort, the more rapid the fermentation. And that may be okay, but it's different to what it is if you don't have that rapidity. If I can go back to the hot wort stand,
Sure.
that's got to be consistent. It's you can't go into say, well, I have a 10-minute stand in the whirlpool, and then say, well, actually, I've got it in the whirlpool. I just need to go and pick the kids up from school, and come back an hour later. It will change the product. And that's all to do with DMS control. Nobody on the home brew scale is going to measure dimethyl sulfide, but you can control it if you know what you've got. If you know how much of the precursor is in the malt, and you trust that value that's provided, if you've got it on your specification, then you can control your operations in the brew house and the fermentation to have a pretty good stab at getting a consistent level of that single flavor constituent, bearing in mind there's more than 1,000 others. So the fundamental tools are enough. It's kind of nice to have a microscope so that you can inspect things like your yeast. Might even do a viability check on it and a yeast count on it. So if you've got a microscope, that's a kind of a handy tool. And if you've got some facility for measuring pH, that's kind of useful. But the bottom line is you don't have to have too much in the way of sophistication, but you do need to understand your raw materials, and you do have to have a highly consistent way of doing things. And of course, not forgetting the ultimate, which of course is hygiene, and the hygiene status. Let me give you another example, Brad. Of
Sure.
I was a bit of a rebel when I was a QA manager, and I used to go nuts. And there were two things that drove me nuts, and the first was I arrived and there was this huge room that was just full, wall to wall, with beer. And I said, "What's this?" And they said, "It's our reference beers." And I said, "What do you mean?" And they say, "Well, it's every beer we've brewed, and it's a sample of it." And I said, "Well, what have you got it here for?" And they say, "Well, if somebody complains, we can check." I said, "Well, wouldn't it be better to have in place systems that nobody's going to complain?" And there's no point in looking back retrospectively. If you've packaged a beer that's you're an idiot. Let's make sure every beer is not.
Yeah, we've
rubbish.
already sent it out and it stinks now. So what?
Yeah. Well, that leads me on to the other point. So every Wednesday, I used to have a meeting with my assistant and the packaging manager and his assistant. And we used to present all this microbiological data, all these plates, agar plates, three-day plates for aerobic organisms and 7-day plates for anaerobic organisms. And we present this, and my assistant would say, that was filthy on that day. The head was filthy on that day. Look at those counts, too many to count. And the packaging manager would yawn and turn to his assistant and say, "Well, what happened to the beer?" And they say, "Well, it's already been drunk. It went to Birmingham and it's been supped already." And what's the point? What's the point in having all that historical information? So if it's something like hygiene, it's far better to make sure the brewery is cleanable and there's no dead legs and there's no hidden bits that are not getting cleaned, and to make sure you've got good cleaning solutions. And if you're on a significant scale where you can actually measure things, just check the caustic strength or something like that. And make sure your process is robust and you're cleaning things properly, rather than analyzing endless play. It's great job creation in terms of people scurrying all over a brewery making measurements, but the really fundamental thing to do, and the QA approach, is to design the brewery properly and have the equipment cleanable and making sure it gets clean with the frequency it should get cleaned, and put the onus on that rather than the other way around. Again, at the Brewing Research Foundation, or BRF International, we champion rapid microbiology. Now, I'm not advocating this for the home brew, but it would be possible. And this is something called ATP bioluminescence. And if you've ever seen, I don't know what they call it where in your neck of the woods, but the fireflies over here, are they firebugs or lightning bugs or whatever? Anyway.
Yeah.
So these fireflies, the male beams out light from its rear end, and it's a mating signal. But you can take the enzyme in the system that does that, and you can put it into an analytical check, whereas you can swab a tank and put it in this reaction mixture, and it produces light. And if there's any ATP, which is where if there's been any organism there, it produces ATP. and you can pick up that ATP, and the more ATP, the more light. So by measuring how much light is coming from that swab, you can see how clean it is. And that you can do that in at most in a few hours, and ideally in minutes. So this is virtually instant microbiology, and that's better than endless plates. But I'll never forget when we first brought that out, and there's a brewer in England, he said, "You're costing me money." I said, "Well, how's that?" He said, "Well, we use the test on the tank, and we don't like the results, so we clean it again. And before that, we would never have cleaned it again." And I say, "Well, it's up to you. You either believe it or don't. And if you don't believe in it, don't do it. But if you do believe in it and it's the right thing to do, then clean the tank again. But better to get in place systems to properly clean the tank, then you don't have to do it again." And again, it all comes down to right first time, making sure things are done properly and they don't need redoing. Common sense.
Yeah. So, I mean, this is when we talk about statistics and we talk about tracking the various measurements, and we actually get into the control end of things. You think it's much better to take a proactive approach, right?
It is. Totally. Now, on anything like a sizable scale, there are measurements you'll make. So a brewer's going to be making measurements of, say, total impact oxygen. They're going to be measuring the ABV, the alcohol by volume of the beer. In our case at Bass, we measured DMS. You might be measuring foam stability, all of these things. And you plot these, you chart them out and see how the trends are going. But, at the end of the day, they should be trending correctly and they should be within specification if you've got the thing set up correctly. So it shouldn't be an exercise in, we're drifting and it's going out of specification. You should make sure it's not going to do that because you know what you're doing. But yeah, any significant brewing company, you go into any substantial commercial brewery, they're going to be plotting out data, and you can see just how good they are at achieving consistency right the way through the process.
Yeah, I get a lot of homebrewers writing me and they'll go, my original gravity keeps coming in low or my mash temperature keeps coming in low. What should I do? And I'm like, probably change your process, right?
Well, yeah, or do it properly, Yeah. Do it right.
But I mean, so just to sum up here at the end, what things do carry over for the home brewer and what are some of the lessons we can take away?
Well, the lessons are do it right the first time. Celebrate your raw materials. Make sure you realize that your beer, in fairness, is only going to be as good as the raw materials you use and the process that you're going to apply. So worry about those raw materials. And the one of those that I think that many people worry about or don't seem to pay attention to the most is water. It comes out of the faucet and and they say it's okay. I mean, here at home, sometimes the water coming out of the faucet has clearly got a taint in it. So the quality assurance approach will be, well, let's treat our water, let's carbon filter it or something before I brew with it. But at the very least, smell it and taste it. So the golden rules are: look at your raw materials, make sure that they are within specification. And any malt should have some analytical information you should be able to get for it. And the same with hops and so on. Apply them properly, make sure they're what you expect them to be, and control your process. Make sure the brewery is cleanable, it's hygienic, and it's capable of consistent operation. And if you're operating it correctly, you know what you're doing, and you're controlling times and temperatures, and it is important you're able to know how to control the temperature, then at the end of the day, your process stream should come through consistently. So the actual measurements you need to make are, not that many, but you do need to apply the sensitive measuring devices which are located in and around your body, particularly your head. And use your brain as well.
Yeah, always important.
Yeah.
Well, Charlie, here at the end, I want to give you a moment to talk about some of your books. I know you've published some recently, and I think you may even have one or two still coming up, right?
Well, actually, this topic is the subject of the book that I've just sent over to the publisher. You may be aware that I've got a series in the American Society of Brewing Chemists.
I do recall that. Yeah, I think you mentioned it last time you were on.
Yeah, so it's a 6-part series all about quality. The first one was foam, the second was flavor, the third freshness, the fourth color and clarity, and this fifth one is quality systems. So the sorts of things I've been talking about today are in that fifth volume, which should be coming out early in 2019. Then I'm at the final stages of writing a book called In Praise of Beer, which is more a general read for anybody who's interested in beer, not only for brewers.
Sounds like a religious book, huh?
Oh, yeah, something like that. Well, it's Oxford University Press, and I had a book called Beer, Tap into the Art and Science of Brewing, which went into 3 editions. And they said, could you do the 4th edition? I said, can I do something different? And so it's if anybody's familiar with that book, it's similar, but probably a little bit more tongue-in-cheek and a little bit more, not exactly risque, but a little bit more opinionated, should we say. So, and I'm nothing short of opinions, but so that hopefully will be out sometime later in 2019. And actually, I'm writing with a colleague on campus, a guy called Bill Ristenpart. We're actually writing a book on brewery engineering. I'm not an engineer. He's a chemical engineer, but my contribution is to soften it and put it in slightly more gentle, not hard engineering terms. So hopefully that'll be a useful read for anybody who wants to.
I'm an engineer, so I appreciate that.
And I'm sure there's one or two others. As I say, I'm writing a soccer book with, and hopefully there'll be more of those to come as well.
That's the one I'm looking forward to.
Well, like I said earlier,
I had a hard time finding your old book. I actually was looking it up earlier.
Yeah, you probably have to pay a fortune for it. But I have a copy right here. So.
There it is. Yeah, hold it up just a little. There you go. In Keeping with the Wolves is the title of it.
That's right. In Keeping with the Wolves. So
if you're into Charlie Bamforth memorabilia, you can pick that up.
1990. I'll tell you a story. 1991. That the village I lived in the south of England, we needed to put a new roof on the village church, and I volunteered whatever any profits I made on that book that could go to the church roof. And they said, thank you very much. And then somebody else who lived in the village was Phil Collins. And he said, I'll do a concert, and whatever that generates, you can have. So one of us made more money than the other.
I wonder which. Well, Charlie, thank you again for coming on the show. Really appreciate you being here. And I hope you'll keep us in mind, even during your retirement. Hope we can get you on as a guest again.
Well, you know where to find me, so I can't escape, can I?
Yeah. But thank you again. Again, my guest today was Dr. Charlie Bamforth. He's professor of malting and brewing sciences at the University of California at Davis. Thank you, Charlie.
Thank you very much.
Well, a big thank you to Dr. Charlie Bamforth for joining me this week. Thanks also to our sponsors, Craft Beer and Brewing Magazine. They have a new Craft Beer and Brewing Magazine podcast, which I encourage you to check out. It features some of the top craft brewery owners and brewmasters discussing brewing techniques and flavors in beer. It's the podcast for those who make and drink great beer. You can find it on iTunes or at beerandbrewing.com/podcasts. And also Blickman Engineering, creators of the Riptide Pump. Designed for homebrewers, this pump features a whisper quiet sealed housing, a removable tri-clamp stainless steel head that's easy to clean, and a built-in relief valve for easy priming. Get the Riptide Brewing Pump today, another great innovation from BlickmanEngineering.com. And BeerSmith 3 is available for download for both desktop and mobile platforms. BeerSmith 3 adds mead, wine, and cider support, new Whirlpool hop options, support for high-altitude brewing, and a whole lot more. Check out BeerSmith 3 and get your free 21-day trial from BeerSmith.com today. I hope you have a great brewing week.